So that started to record now. And I'll start presenting what I have. Okay. So this is the November 1st OpenFaaS community meeting. We haven't had one with the whole group for a little while. So we organised 3 great talks for you, just so it's something a bit more for today. Many of you know me. I'm Alex, founder of OpenFaaS. Started this project off, and I'm now at VMware. And I've got most of my team on the call tonight as well. And they've helped with some of the work that I'm going to show you today. So in this session, we're going to start off with Andrew over at TUCOWS. He's been working on the OpenFaaS Nomad provider that Nick Jackson started at HashiCorp. And he's going to tell us a bit about what is an OpenFaaS provider, why should you care about them, and what's he been doing with them. I'm then going to give you a tour of OpenFaaS Cloud running on GitLab. And then you'll also see a few demos around that. Finally, Ed will close the session by showing us the AWS Fargate Provider, and hopefully also tell us a little bit of why you put that together and what problem you were solving with it. So this is our community and our contributors, also known as Team Serverless. I just wondered, is there anybody on the call today who's here for the first time or who's new? Maybe hasn't been on a call before?
Me.
Hi.
Hi, Julian.
Hi.
Hey, how's it going?
Good, thanks. Have we got anyone else? I think Thomas, maybe?
Yeah, so we've gotten to speak, but this is my first community call.
Great.
It's my first too. Here we go.
Who's that? Oh, hi, Daniel.
Daniel. Hey, how you doing?
Good, thank you.
It's
And
my first too.
who's that speaking?
Philippe.
Philippe. Salut. So Philip has been writing some great blog posts about OpenFaaS. He works at GitLab. And I see Mano. Not sure who. I don't know if we've met before. And Paul. So you're all really welcome. I want to extend a warm welcome to you. And if you've not contributed to the project, I'm sure we can find some way for you to get you on here, some way of getting your first commit or pull request in. And if that's not for you, then any feedback that you have would be great. Just get stuck in community. If you're not in Slack already, I'll show you how to join at the end of the call. But you're all very welcome. So this team of contributors spread out all around the world is really what led to OpenFaaS gaining its popularity and its usage. And one of the things that really proud about in the community is the BOSI award that we've just been awarded from InfoWorld, the best open source software award in cloud computing. And that's really for all of you that are on the call. And I'm hoping that, even the new people, what you'll add over the next year will hopefully get us similar award next year if we're lucky. So I think this is something to really celebrate. And it shows that we're doing the right thing. And when you work in a community like we're doing even now, that this really gets noticed by people. So I'm now going to hand it over to Andrew, who's going to tell you about OpenFaaS providers. Andrew, I'll start a timer now, and you have about 15 to 20 minutes.
Okay, thanks, Alex. Hi, everyone. My name is Andrew, as Alex introduced. I'm doing principal engineering over at TUCOWS. We do domains and fiber, internet and mobile carriers and stuff. So I'm relatively new to the project, but I saw a gap in the technology stack that TUCOWS is running, and that was with we chose Nomad as our provider, as our container scheduler. And I saw that Nick had started one, and there was a bit of no activity on that project, so I started to pick up the missing features so that we could be parity with the Kubernetes provider and the Docker Swarm provider. So without further ado, I'll start my presentation. Need desktop one. Let's do that. And I will present this. There we go. All right. Let's see. Yeah, so like, what is an OpenFaaS provider? I'm sure there's a few people who don't know, so I'll just briefly talk about it. Yeah, so OpenFaaS has a nice gateway where it basically acts as a reverse proxy to your provider of choice, or your backend, your container scheduler of choice. And there's a few things that it cares about. So basically, it's the backend for OpenFaaS, and its job is to implement all the things that we care about in the project. Let's go back. Some of the responsibilities. So you have 6 basic responsibilities of the provider. There are optional ones too, but basically returning the list of functions from your backend and all the metadata included. So that's like annotations, labels, the image, like all those things that is required for the provider to do its job. The actual deploy handler. The deploy handler is in charge of actually creating there's someone with noise in the background. I don't know if they can mute, but thanks. That's in charge of actually creating the functions in your container scheduler and propagating all of the metadata that comes in from either the web UI or the FaaS CLI. And it's responsible for just deploying that into the environment. The actual function proxy, this is the implementation for proxying all of the actual invocation calls from either just simple web requests or FaaS CLI invoke. And its responsibility is to proxy to the right thing and even do load balancing under when you have a lot of instances of that function when the demand of that function increases. So replica reader, just returning the amount of replicas for that function itself from your backend. Replica updater is in charge of deploying additional instances of that function for more load. And finally, just delete, removing the function from your catalog. Pretty straightforward with that one. And you need to implement that however way is best suited for your provider backend. So yeah, why would you want to write one? In my case, I noticed a gap in one of the community ones, so I just hopped on that opportunity to kind of work with Nick and Alex on bridging that gap. But also from level, it provides you an abstraction layer to your technology stack. Like, you have really fine-grained control of all of the handlers I just mentioned in the previous slide. You can connect with any number of other technologies in your stack. You just have a lot more control for all of the requests that are coming in to the gateway. I did see a Twitter post about someone writing a proprietary backend provider for their stack. I can't remember what they were working for, but
that was we actually have someone from Cisco here, Jox, on the call, and that's like a subdivision called OpenDNS.
Okay.
A scheduler for EC2 that they've built in-house, and they were able to put together a provider basically in a weekend on a hackathon.
Nice. Yeah. So it's great if you have a kind of a proprietary stack for your organization. And yeah, just like if there's a missing one in the community, like the community is growing, however, we might be missing providers that are gaining popularity. So perhaps you'd want to write one for everyone to benefit from for that provider. And just lastly, Alex and team have come up with a Go library that you can easily bootstrap your provider in Golang. It's not required. Like, you can actually write a provider without using this this library, but it's way easier, and it's basically just provides continuity to the rest of them too. So, and I think my last one is a demo. What we'll do is, yeah, there we go. So demo, what I will do briefly show is both Nomad providers running locally and an example provider I've written for this. So let's go over to our FaaS gateway. Let's invoke just to see if it's working. And let's invoke that. All right, looks like it's working. We have our Nomad provider. It's got 2 different functions running in there. Looks like it's good. What I'll do now is I'll swap out this one with the example one I have written for this demo. So its implementation is using FaaS provider. What we're doing is just instantiating a logger, and what I'll do is just briefly demonstrate the gateway working with this canned response example provider. What I'll do is go back over here and change this here, and I've got a Vagrant environment that will switch that up for me. And let's go back to my source code here. So you can see sort of the proxy or the handlers in action. I've got
zoom in a little bit. If you, I think like command
zoom in.
might make the font a bit bigger.
Yep. How was that?
Yeah, looks good.
Okay. So yeah, we just established some config for demonstration purposes. We just have, I'm just doing the port, but you can see all of the options here for enabling basic auth, enabling health endpoints and whatnot. But this is the guts. So for this purpose, I'm just going to spit out a canned JSON response with example function. And we'll do that one, and we'll also go through and debug the deploy one too. So let's just make sure that, okay, that one should be ready to go. So let's debug this guy. Okay, it looks like it's calling, so that's good. But let's go to the UI just to see. There we go. So now I've just switched the OpenFaaS gateway to point to my local FaaS provider, and now I can just easily test the functionality with my own backend. And so so it's just returning the sample function, and then so let's maybe just set a breakpoint in our deploy here. So let's just try to deploy Figlet. Okay. And we see that we have function create deploy called here. So it looks like it triggered it. So that's good. And that's basically the demo of an example provider that you can get started with. Obviously, the more full-fledged examples are FastNetties, FastSwarm. There's Fargate, which is later in this talk. There's Fast Nomad and Rancher as well, and many more too. And that concludes my demo. Alex, I don't know if you wanted me to cover anything else, but
yeah, could you open the community file and just show us the list?
yes.
While you're doing that, what questions do we have from people on the call for Andrew? Everybody's on mute, so if you're trying to ask, you have to unmute first.
Well, this is something that I can dig into the code a bit later, but I was curious as to the proxying of the actual function calls. Does every function call get proxied through your FaaS provider?
Do you want to click on the function providers there? So just bring the list up. There's a link. There's a link in the screen. There you go.
There we go. Okay, yeah.
I could probably take that one, Thomas.
Yeah, sure.
Originally, there was only one provider, which was in the gateway, which was Docker Swarm. But then when I adapted the project for Kubernetes, that's where this provider pattern came about. And we were going from the gateway to the provider to the function until did some performance testing and figured out we could reduce one hop. And in Kubernetes and Docker Swarm, you can go from the gateway directly to the function with no additional proxying, because they both provide this DNS for you. So you can just look up from the function name exactly one-to-one and hit it. I believe in Nomad, the way Nick originally did this is he made use of console and some of the circuit breaking technology. So for them, they go first to the provider and then on when they're proxying. And the only time the OpenFaaS calls go to the provider is if it's one of the API calls, so something that the provider actually needs to do. Make sense?
Yeah, that's what I thought it was, but I wanted to double check. That makes perfect sense. Thanks.
Yeah.
I have a question about that. When you're going directly through the function, is scaling and provisioning the function all done, like for example in Kubernetes, or is that something that happens in OpenFaaS? Like as far as like if you were to get a lot of traffic and have to scale up to 15, 20 instances.
Good question. So auto scaling is documented on docs.openfaas.com in quite some detail, but just for quick summary, with every provider, the backend doesn't necessarily have its own autoscaler. Kubernetes luckily does. It has the horizontal pod autoscaler, but Swarm doesn't, Nomad maybe doesn't, and I don't know about the others. So we have one generic one that can work at the OpenFaaS level that looks at the function, the traffic in Prometheus, and then will ask for more replicas and then back that off again using Alert Manager. But if that's not for you, you can actually swap that for HPA in Kubernetes, and we do have that documented as well.
Oh, okay. Thank you.
So HPA is better for if you are running workloads that must be scaled by CPU and memory, something like machine learning, stuff like that.
Yeah, that's probably true.
That respond to web requests. Like when you process web requests, it's better to use the built-in OpenFaaS autoscaler, because that one only looks at the thresholds in terms of requests per second. So they have different scopes right now.
Yeah, that's true. And maybe at some point in the future we may add the CPU memory to the OpenFaaS autoscaler. The benefit of that one is that while it may have a limited scope, is that it works with any OpenFaaS provider, whatever the backend is, even if it's a fake one or you're just returning canned responses. If Andrew finished his canned responses provider, we could autoscale it using the autoscaler, if that makes sense. So now we're kind of running up to the end of this slot. Andrew is on Slack. There's a channel called FaaS Provider. And if you're interested in some of the proxying or just the guts of all of this stuff, that's a great place to go and find out more. If you are feeling inspired to try out a provider, please, ask us your questions. Something that might be interesting is you can see an example here for Hyper that was started, and I don't think it's being maintained by them anymore. But Hyper have a on-demand compute service, so you can start containers on the fly, and so a provider for that might be interesting. Recently, I started looking at, could we do one for Containerd that just runs on a single node for a really constrained device like an edge compute gateway. Maybe it doesn't have any networking, and there's all sorts of things that we could do with this. So if you're interested, please let us know. Okay, so thank you very much, Andrew. Appreciate that.
You're welcome. We'll stop sharing here.
Now, on to OpenFaaS Cloud for GitLab. I don't know, do you have anybody here from GitLab? We've got Philippe.
Daniel's here too.
Hey, Daniel. So I put this poll out earlier in the week, and something happened that I did not expect, which was almost 4,500 people responded to it with 221 comments. And what I asked was, and it kind of is assuming that people are using Git already. I know some people have Subversion, etc. But once you do your push, where is it going? And it seems undoubtedly that GitHub.com, the hosted version, is the most popular, at least among this segment. Close behind that is GitLab, and then we also see other. And when I dug into this, I found that actually there's a new tool called Azure DevOps, and lots of people are using that, a huge amount of people. And that is actually Visual Studio Team Services. It's something that I'm going to go off and have a look at because I'm not really familiar with it. But while we're talking about OpenFaaS Cloud and Git, I thought this was interesting. You can see some of the responses later. So a quick reminder, OpenFaaS, compared to something like a cloud function, focuses on being easy to use. There are no IAMs, there's no cloud formation. Things are just all set up by convention rather than through arbitrary configuration. We're trying to make this very easy to use for developers. So we have over 150 contributors already, and that's one of the reasons why. Within that, we also enable you to run any code that you have. This is something that's really popular with our users. Any existing code that can run in a container on Linux or Windows, not just Linux, can be made into a function and then run anywhere you like and deployed at scale. When I say anywhere, that really does mean an ARM device, whether that's a Raspberry Pi or data center ARM. You can run that on 0% on-premise or 100% on-premise and anywhere in between on any cloud. You even run this on 2 clouds at the same time by using something like Kubernetes, which is really something that you don't get with a cloud function. Now you can take this to any scale you like by potentially doing something like what GitLab do with their build runner pool and have these hosts provisioned and added into your cluster as and when you need them. And the price point can actually be pretty similar to using cloud functions depending on your usage patterns. But the key thing here is not really about price, it's about you being empowered to decide what the limits are. So what programming language do you want to run? Is it Node 10, which is the current LTS version? Well, with OpenFaaS, you can do that already. We already have that available for you. Go 1.11, if you want to use Go modules, again, you can do that. But one of the key things here is really being able to use open source software and decide the limits. So with AWS, you're really looking at something like, correct me if I'm wrong, 128 megabytes as your maximum upload. For Lambda, with OpenFaaS, you can go to multiple gigabytes. And because we're using Docker and layered file systems, it actually works really well. And there's a quick recap on OpenFaaS. Some of our users find all of those points useful, but some of them find other points more useful than others. Particularly Bulletproof is a new user in the UK, and they came about after the GDPR movement. What they provide is vulnerability scanning, security penetration testing. Now they told me that one of the things that they like is the ability to take any scanning tool that can run on Linux, put it in a Docker container, and deploy it in OpenFaaS with no additional changes. The other thing that they like is they actually have quite a large compute pool available to them. They can take any one of those functions and auto-scale them. And so as their customer base is growing, they're able to grow their platform as well. I don't know if, do we have Patricio on the line from Vision Bank?
Hi, Patricio here.
So Patricio has joined us all the way from Paraguay, and this is probably the first bank, at least that is allowed to say about it, is using OpenFaaS. And one of the things that they've started with is back in July, they took part of a Java application that was their home banking system and started carving off parts of that and turning it into Node.js functions. They went from having quite patchy availability and having to firefight that with different alerts firing off to 100% uptime with OpenFaaS. And I think that was achieved in a very short period of time. So appreciate all the feedback and even the contributions that Patricia has been making. One of the other companies that I'm quite fond of is Icon Scout. This is a startup out of Bangalore, the new Silicon Valley, and they provide you stock photography and icons. On launch day, their PHP servers were feeling the pressure and stopped serving responses, but the OpenFaaS functions that were doing the resizing for customers stayed up and carried on serving traffic. And I thought that was a great example of how robust this is. So these are some other end users, and actually we noticed that there was this sort of common theme starting. These companies were adopting OpenFaaS, and it wasn't the developers that were necessarily driving this. It may be DevOps managers and leaders within the team, and the rest of their colleagues weren't necessarily as technical or really as deep into Docker as what we were. So I want to talk a bit more about that. If you were to write a function, really you can use our CLI to scaffold that. So you pick one of the languages that's perhaps already supported, like Python or Go or Java. That generates a handler for you in a standard way, and a way of you specifying what your requirements are. So whether that's some jars, maybe something on Maven Central, or in this example, pip modules. We then will, when you do a build, take that and combine it with a Python best practices template. This is something a bit like you might have seen in Heroku called a build pack, or maybe in Cloud Foundry. Once that's been combined with your code, we produce a Docker image that can then be put into a registry, such as Harbor or the Docker Hub, and then you can deploy it. So that's another difference between the workflow for functions in OpenFaaS and Cloud Functions, is that we're building Docker images that are immutable, and that's what we're shipping. Okay, but really, if you look at this overlay here, everything on the left is what Patricio's developers care about. And the guys in the larger teams like BT Research, they have engineers who just know how to write Python code, and they don't really care about the infrastructure or anything else that's going on. They want to write the handler, put it somewhere like in Git, and have all of the rest taken care of for them. So just keep that in mind for a minute. So this common theme was noticed. Early adopters were supporting less technical teams who maybe weren't as deep into the container world. And they actually started building their own CI/CD systems to try and solve some of this problem. But actually, you know, when you move away from the source, you don't always get to the best solution. And really, we thought, could we reduce some of this friction here for those teams? What they wanted was more collaboration and more feedback out of their OpenFaaS. And so we applied some best practices, really, which involved centering everything around Git, which turns out is absolutely not a new idea, as many of you I'm sure are already doing. So we wanted to make working with OpenFaaS in a large team with collaboration and feedback seamless. Okay. This is Ivan Pedrasas from London. He is a well-known Kubernetes speaker, and he says at his company, he has this pipeline where you push to Git, their CI system builds, deploys their code, and they get an endpoint. And he thinks that's what serverless should really be about. This is GitHub, and they just released some proprietary technology called GitHub Actions. But what this enables you to do is to do a CI workflow directly in their UI. So you may be not having to go out to Travis or Jenkins to do that, and you can do it in one place. But again, this is centered around Git as the source of truth. And then finally, Alexis Richardson, who is chair of the TOC at the CNCF, a well-renowned speaker on Kubernetes, he's coined this whole term of working around Git as GitOps. Now, GitOps means that you put your code into Git, and that triggers deployments. And when there's a problem in the system, we look back at Git to realize what we should have deployed there. If you combine GitOps and functions, this is what you get. You get OpenFaaS Cloud. Now, going back to those problems that we're trying to solve around feedback and collaboration, you get an environment that is largely managed. So it's much easier for someone like Patricio to give this to his developers, and then they are just pushing their code into one place. It's multi-user, which again is something that with the base OpenFaaS you don't get. It's giving you a personal dashboard so you can drill into just the detail that you care about or your team. And then we have this CI/CD workflow through GitOps, which I think is the most important part of this, is giving people that pipeline that we know works, that's shrink wrap, that's got everything put together in the same configuration. And then you get feedback and as detailed as you like, either via the GitHub UI or from GitLab. Now, in addition to this, to get more feedback and as a request that we had from the community from even the earliest days, we put together a community cluster that's free to use, and you can just get into that. I'll give you instructions at the end of the talk, and from there you can deploy your functions live on the internet of HTTPS. So conceptually, OpenFaaS Cloud, it says GitHub here, but imagine that GitLab works exactly the same. We set up our code in a workspace on our laptop. We do a Git push. In the middle of the screen, you see my repo there, owner name and the name of the repo. The system will then send a webhook into OpenFaaS Cloud. We securely verify it, and we package up your code, build a Docker image, and deploy it. So it's exactly the same workflow that we saw that the developer was doing manually, but it's completely automated. And at the end, you have an endpoint. How does this work? Well, when you look at this through the lens of GitHub, the way this works is there's either a push event or installation removed event. A push event simply means that we need to build your function, and that goes through to GitHub push. And a remove event goes to garbage collect, which calls the OpenFaaS API to delete those functions. Now, with GitLab, we don't have the same level of integration available to us. So the way we've done this is we'll do push the same way, but adding and removing is done by tags. So if you put a tag on your repo of OpenFaaS Cloud, an event comes here, we'll start building it. If you remove it, we clean it up. Trust and signing is very important for a system like this. You do not want someone finding the URL for your Docker builder and going crazy. So GitHub signs the JSON message, computes a header, this is called HMAC, and sends it along with the message. At the other end, we have the same secret, and we do the same again, and then we know that it's from GitHub, and we will build it and deploy it. With GitLab, it's slightly different. They send a password in plain text, but we apply the same technology. And then once we're within the cluster, after the first function, everything is signed with a different key between the functions so that they know that there's no tampering going on. I want to tell you how the actual CI/CD part works. There's a lot of boxes on here, but there's only 3 things that are happening here. The first is we're creating a Docker image and putting it in the registry. The second is we're storing any logs that came out of that build. And the third thing is we may be importing secrets. So to create the Docker image, we'll clone your repo, check out the specific SHA, and then make a tarball. The tarball goes into a builder called BuildKit. This is from Docker. It's a very fast, highly efficient image builder, and then that is stored in a Docker registry. The logs are stored in an S3 bucket, and it could be Minio if you're self-hosting, and then the secrets are encrypted and put in your repo as secrets.yml. That can be decrypted and attached to your function at runtime, and then finally you see post or put system function, and that's going to the OpenFaaS API. Hopefully that makes sense. This is what things look like on the GitHub UI. I'll show you GitLab in a minute. We have done a push, and we can now see the status here, and we've got one status per function, and these have got a tick on because they've successfully been deployed, and then we have one for the stack overall. And every time we do a commit, we'll get this. So if we remove a function, we'd get only 2 here. If we added one, we'll get another status. When you click on the status, you get a link off to the function, to the endpoint, and you get all the container logs. And this is what your dashboard looks like. So on your dashboard, you can see, is it a private repo or public? How many replicas have you got? Somebody, I think Daniel was asking about auto-scaling. Again, you get feedback here. And then when you drill into this, you get even more data, like how to run it on your own OpenFaaS locally. In terms of serving the functions, one of the things that's important here is that OpenFaaS is largely stateless. So the way this is drawn is by reading the functions that are in the cluster, looking at their labels and annotations, and using that to draw each row. So we have system dashboard goes to list functions goes to the API gateway, gets the list, and then renders them. One of the things this means is that it's highly efficient, it's fast, we don't have to have a relational database added in here, and any state or logging that we need, we can actually drop into external systems. So I'm now going to give you a quick demo of how GitOps looks like with GitLab. We have a cluster set up separately, and this one is my current dashboard. You see I have something deployed about an hour ago. What I'm going to do is get myself into GitLab. This is one that we've deployed locally, and we'll start a new project. And this one's going to be public, but we support private as well. And then what we can do is clone this. Open it up with something like Visual Studio Code. And then we can use the OpenFaaS CLI to create the first functions. This is exactly what we saw on that diagram earlier. So call it hello. This pulls down the templates from Git and then structures the text for us. We're just going to rename the YAML file to stack YAML so that we have a convention and we know exactly what we're looking for. Here's our Python code, and it just returns the input that came in. I'm just going to put hi, my team. That's it. So we're now going to add this to an initial commit and the push. Before we do that, remember I said there was one more thing for GitLab, because they don't have this idea of GitHub apps and integrations in the same way GitHub has. We have found the way to opt in. So if you go to your tags and you put OpenFaaS Cloud and hit save, this will now tell OpenFaaS Cloud that this is a repo that we care about building. And now we're going to do the push. That's been pushed. We can see the code here. Already, immediately, we've got a commit status that's appeared. We should be able to go through to that and see some of the functions popping up. Once this gets deployed, it will appear live on my dashboard. And I think we've got some messages coming into Slack that should be able to tell us what webhooks we were receiving. So there's the code, and that build, including pushing to the Docker Hub, which is on, I believe, the west coast of the US or the east coast, took 33 seconds end to end. We have the function deployed here, and the commit status has now got a tick on it, and we'll see every function that we have within the repo will get its own commit status. If there's a failure, it will block it there as well. Let's take a look at it and see if it worked. We've got our URL here. Okay, there we go. And we've got the text hi team. So that's working. Pretty happy with that. So what have we done? We've created a new repo in our GitLab deployed on-premise. We have OpenFaaS Cloud deployed on-premise. We've then pushed code, and the image has been stored in a Docker repository for us. Here it is, fully versioned. We can go backwards and forwards with this. And there's actually a cool feature that we've just added, which is to run on my own OpenFaaS Cloud, well, my own OpenFaaS on my laptop. Now, if I set up my gateway to my local machine, paste this text in, and that image, which is existing on the Docker Hub, has now been deployed on my own OpenFaaS on my network or my laptop, which will allow me to debug it. So if we head over to that URL, we'll see it on here somewhere. Hello team, there it is. And so that allows you to have this full loop. You can debug things, you can get into the logs from the same page. We're going to be adding some more information here soon. We've got the invocations over the last 24 hours, positive, negative. You can even get a badge to put onto your repo from here. Okay, now, so that's just a basic hello world. One of the other things that we did was Ivana helped me with this, who's part of a full-time team, is we have this GitHub repo called bot tester, and this uses the bot from the OpenFaaS workshop. Let's see if we can find Ivana's page first. We see the issue bot was deployed an hour ago. It's been invoked 81 times. What this does is if you paste in an issue, it tells you the sentiment of it. Was it positive or negative by running an OpenFaaS function? Now on this thread from earlier, we actually have a few bits of text, people talking about different open source Git management tools and what they think about them. Here's one of the messages, and this guy seems to be quite positive about one tool, but not so positive about Bitbucket. I'm just going to put a message from Charles, hit submit issue, and then Ivana's function is going to run. It's exposed publicly to the internet. So GitHub sent a webhook there. We could equally have written this on GitLab in exactly the same way. And you see the bots put a message of review. And that means that it was actually quite negative, or we found that it was quite negative. Now, if you put something positive, it would have put a positive label on it. So just to show you that this is live and all connected, what we were going to do is uncomment the code. I don't know, Ivana, do you have your...
Yeah, it's in my repo. I'll share you a link on Slack.
Here we go. Is this the one issue bot?
Yes. It's...
We go into your code. Now, I'm doing some driving this, but Ivana could have been doing this from her laptop at exactly the same time.
Yeah, these are these lines. These are a few lines of code that commenting, mentioning the owner of the repo, so that if an issue is with negative threshold and is marked with review, then it's expected the maintainer to take some action, the owner actually, to take some action on it.
Yeah, so, you know, perhaps if something needs a review, we should ping the user, and so that will expect them to come in. So what we're going to do is uncomment that bit of code, just like before. We're going to hit commit. And then that complete workflow that I talked about earlier is going to take place. The code will be cloned from the GitLab repo. We will run the CLI to create a tarball doing that templating. We'll pass that into BuildKit. BuildKit is going to update the Docker image in the registry. And because it already built this earlier, it should have a cache, so it'll be quite fast. We'll get the container logs from the build. And you actually have a sealed secret, I think, don't you? Or did you not need one for this example?
Yes, I created a secret because it needs an authorization on the repo.
Okay, so what did we have to put in here that was secure?
We need our token for GitHub so that it can operate on my repo in GitHub.
Okay, so there's a command in the OpenFaaS CLI that will take a plain text secret or a plain text file and turn it into an encrypted file. And then if you place it as secrets.yml, OpenFaaS Cloud will read that in, securely attach it to your function, and then that's how Ivan is able to post back to GitHub through the API without specifying it here, which I think is something that's really useful. So let's take a look at the dashboard again. It looks like it was deployed a minute ago, and we've got the SHA here, but if we just want to make sure, what we can do is click on this, and it will take us exactly to the diff, and we can see, yes, that is the commit that we were looking for. And let's try that example again. Let's see what happens now. Nothing like a live demo. There we go. It worked. So live in front of your eyes on this call, we've been able to do a complete GitOps workflow. We've got secrets here. We've got a dashboard. We've got rich feedback. We can get container logs and get exactly the data that we want. Now, we showed you a few weeks ago how to use GitLab and OpenFaaS by creating a custom YAML file. What you'll notice about this example is there's absolutely nothing custom about this at all. We've got one tool that works on GitLab and GitHub exactly the same way, and there's no burden on you really other than adding the tag. I think that was everything that we were going to show you, but there's actually, there's one more thing. Patricio again, he created this pretty cool function, and this is deployed on the community cluster right now. It generates QR codes, but you can actually embed this in a HTML page. And what it does at the end is it takes some text. So in this example, it says Team Serverless. We could just change this to something else, like let's put Cloud. And you'll see, right, is generating a different barcode, reading the string in, and his source code is publicly available. If we go over to his dashboard, we'll be able to see it when he deployed it and everything about it. So that's another part of that element of collaboration.
Alex.
Go for it.
Hi. I just want to add something. That function is not intended to make just QR code. It's not. It can generate a lot of different kind of barcodes and code, 2D codes and 3D codes.
Okay.
It's not just limited to QR codes.
Makes sense. So you can, what Patricio is saying is you can actually, the library that's being used here is very rich. It can generate any kind of barcode that you like. And so this is just an example of some of the stuff you can do, and then you could embed this on your website. That's what OpenFaaS Cloud looks like. We've got a few minutes left, and I just wanted to sort of sum up what we saw. So OpenFaaS Cloud is bringing a portable, multi-user serverless. In fact, when I showed you that dashboard, behind the scenes, I was being logged in with OAuth through GitLab, which means that unauthorized users cannot get to your dashboard. You can manage that through a customers list. The same for GitHub. There's this developer native workflow now, which is working through GitOps to what this best practice is, rather than going back to zip files, back to the ways of perhaps some of the workflows that we've seen in Cloud Functions, editing in a web editor. We're actually using Git in the center. And this has given us a really rapid iteration to get from just the idea to putting that into production. There's a side note here, because when you look at this with GitLab in particular, you can go from 100% on the cloud to 100% on premise and anywhere in between, as it makes sense for you in the business. And I think that's something that we're really excited about. So the OpenFaaS Cloud currently has a deployment with GitHub. GitLab is available for early testing if you would like access. We're looking to have the code released from public repo probably within a few weeks. I've got a couple of minutes now. Has anyone got any questions about what we've just seen?
Alex, is the timeline or the roadmap for the release of those things public?
Yeah, so this is available if you want more information on the OpenFaaS Cloud repo. There's someone called Lebo Pin. Can you mute your microphone, please? Let's see. There we go. Okay, so is everyone still seeing this?
Yes.
Yes.
Yeah, great. Okay, so here's the core roadmap. This is split into a few different segments. We've got the core experience, which covers things like the HTTPS and the wildcard DNS. I don't know if you guys noticed this, but by default, everyone gets their own subdomain here, and then the function is on the right-hand side of that. We've got the log storage here, Kubernetes native installation. There's not much left in the core experience. Around the developer story, we're looking at things like, how could you say, right, well, actually, that work we just did with Ivana's function, we'd rather that went to a canary or a staging endpoint first than we did a Git tag or a GitHub release to promote it to live. That's something that we've not looked at in detail yet. And then in terms of operationalizing this, trust is there, Docker Hub, private repos, OAuth login. This has all been done, isolation through network policies. And then some of the stretch goals include the work we just saw around GitLab. In terms of timing, the pull requests are all open. So if there's anybody from GitLab who wants to take a look at those, maybe the approach we're using with the tags, etc., this is all out in the open. You're welcome to take a look at it. As soon as these are merged and they're in master, they can be released.
Great, thank you.
Welcome. Now, I know there's a number of people in the community, if you're on the call, that have got GitLab or that are using GitLab. Have you got any questions or any feedback?
So I see you running this in GitLab, but on the public repo, I think it was just saying GitHub. So does this require a lot of workarounds, or just the one that you showed in this demo in order to run in GitLab?
Does it require workarounds?
Or like additional configuration rather than the GitHub implementation?
So what we've done is rewritten some of the functions, not all of them. So where you have things like the pipeline, the build pipeline, that's exactly the same. It's really about the initial event and how it gets in. And then the statuses are updated slightly different as well. So rather than GitHub event, we have a GitLab event function that's maintained separately, built and tested separately. There's a GitLab push, but the garbage collect, for instance, is exactly the same. If you wanted to actually look at how you deploy this, I think, Martin, we've got that in one of these pull requests, haven't we? We've got some documentation.
Yeah, I'd love to check that out.
So I have the documentation in the GitHub event function.
Okay.
You need a couple of additional steps to set up your own. instance?
So the way this is working at the moment is through system hooks for the main events, because GitLab doesn't have this concept of GitHub apps. Once we get those, we're either looking at push, or we're looking at maybe you destroyed the project, or maybe you added a tag to it, or changed the visibility, or what have you. Main things there we're doing are checking, are you a valid customer? Looking up some data about the project, is it signed correctly? And then we'll either build it or reclaim it. But by and large, because OpenFaaS Cloud has been built with functions, we're able to swap in and out bits as we need.
Cool. That definitely answers my question. I saw the pull request about a week ago, adding those GitLab hooks.
Yeah, Martin has done a lot of the work on this. He's doing a great job as part of the full-time team in Sofia, working closely with the others on the call as well. So what we want to do now is get this into the hands of more people, especially GitLab users, because as you know, GitLab and GitHub work slightly differently. There's some different assumptions about various things. Great,
Yes.
Okay.
Nice.
Have we got anything else before we go on to Ed's demo about Fargate?
No.
Okay. If you guys want to find out more, there's a link that I put in the Slack to join. We have this channel, OpenFaaS Cloud. There's a lot of different people in here. There's discussion. We've been looking at what would it take to run on a proxy. We actually managed to do that with Thomas. What would it take to run in an air-gapped environment where you're completely offline? And so it'd just be great to hear from more of you if you think this is something that you could use. Okay, so over to Ed, and we've got about half an hour left of the meeting. At the end of that, I've just got a few words and then we'll close up. So Ed, on to you.
Thanks, Alex. Do you want to swap sharing? Oh, let me just walk around the room. The lights have gone off. Okay, great. So as Alex said, I've been working on creating an OpenFaaS provider. I attended an OpenFaaS workshop in Peterborough in June, and I was chatting with Alex about how the provider model worked. And I was quite struck at how extensible it was. But we wouldn't be having to rewrite a great deal to get the full OpenFaaS experience, but hosted in AWS, our kind of way that we run things in AWS. So yeah, why did we create this provider? We're currently using cloud functions, but they don't really align exactly with our, to steal a HashiCorp phrase, development tower, which is to use open source software where possible, and use open source software that has a strong community, and choose tools that are simple to use. And I was struck by how OpenFaaS would align very strongly with that. So I really wanted to run it for our engineers, but we don't run Kubernetes, and we're not running any schedulers that were currently supported. So I thought, looking at the provider model, it wouldn't be that difficult to get it up and running in AWS. But I also didn't want to run any other servers in our AWS estate. I wanted it to be similar to the cloud functions, so no extra infrastructure to manage. And we wanted to keep the cost to a minimum. So that's why we chose Fargate. And Fargate is a system to run containers on demand. So I'm going to do the standard sort of deploy a function, invoke a function, using a running instance of this. And we'll also try and put some load on that function and see the Prometheus alert manager scale up that function. Okay, let's get out of here. So we got the OpenFaaS portal running on Fargate. To prove that it's running on Fargate, we can jump over to the Fargate UI, and you can see here that we've got a number of services. We've got the gateway service, which runs the provider's sidecar. So if you click in here, you can see that we've got inside the task. I appreciate that this terminology is may not be familiar to all people on this call, but this would be similar, I guess, to a Kubernetes pod. So we've actually got three Docker images running here. I'm going to come back and talk a little bit about this KMS one, but we've got the standard gateway that communicates with the Fargate provider in the way that Andrew showed us in the first demo. So we've got that running. Let's just refresh this. We're going to deploy the Figlet function. It can take a while for these functions to, one of the things we discovered with Fargate is it's not super quick to spin up a service from undefined. And I'm going to go through a few of the components in the Fargate system, but once it's up and running, it's not too bad to go from 0 replicas to 1 or to scale up, but there's a bit of a lag for the very first defining of the service. So we've got the service defined now, and we said that we'd like 1 replica of it, and we've got that, and it's still waiting to become a healthy service. So I have to give it a little bit of time. You'll see it pop up here on the portal. Oops. Yeah, it's still spinning up, but whilst it's doing that, I'm going to get my, there's some chat here. What's going on? Okay, cool. Everyone can hear me okay?
Yeah.
Yeah.
Yeah, you've got the classic Wilde true loop there. I see.
Yeah. What's going on? Let's have a look. This should have spun up by now. So it's running. That's good. Should just see if it's got a healthy status. It all looks fine to me. Let's give it another go.
How long have you been working on this, Ed?
I've been working sort of off and on in my spare time since June. I've got a young family, an 18-month-old and a 3.5-year-old, so I don't get an awesome amount of time to do sort of open source development.
Yeah, but I think you've done a lot in that time. I mean, it's almost feature complete if it isn't.
Yes, I think we support almost. Yeah, I think we support every feature that you need to be a valid provider. So we're spun up now, so that's great. We're also running Prometheus here, so we can have a look. You can see that we've got an alert defined so that when you get a certain number of requests per second, this is going to call back into the gateway and ask for a scale up for that function. If we click on that rate function, we'll see that and execute it, we're not getting any data. So if I start this, so basically here we're just going to call the Figlet function in a loop, and I don't think we need this callback thing because we're not going to call it asynchronously. Oops, that's not working. Yeah, let's see what's not going right there. Let's try that one.
That's the async one that you've got there.
Yeah, that's working. I just wanted to see, have I got the wrong load balancer URL? Let's just try this outside of the while loop.
You can also get that off the dashboard. Yeah, now put -d message.
Yeah, so that seems to be working. Yeah. So I'm not sure what's wrong with the, I was running this earlier on. It seems like the curl isn't taking into account the certificate.
Yeah, change the parameter.
I did have a, let's try that again. Try that one more time. Oh, great. Okay, so we're getting some load now. So you can see here that we're in that, I'm not a Prometheus expert, but it's obviously recognized that the value's gone above the threshold and is about to fire the alert. And I think that's the pending state, if I understand correctly.
Yeah, it's now going to count up for, as you can see, 10 seconds. I think it needs to hold it for 10 seconds at that rate for more than 5 seconds in the expression.
So now it would have gone off to the gateway. The alert manager would have triggered the gateway. And so if we go back into ECS now, we should see that it's scaled up that function. Just bear with me, go back to the right screen. So yeah, you can see now that we're wanting 4 replicas, and it's going to be busy spinning those up behind the scenes. So you can see it's activating the other 3 instances. Okay, great. We got through that demo in the end. Thanks for bearing with me. So that's kind of the basic flow that I wanted to show. And then I'm going to dig a little bit into some of the components. So when writing this provider, as Andrew showed, you've got to implement a few handlers. So one of the main ones is deploying the function. And when you do that in Fargate, you need to define a service which determines is the abstraction between, if you like, the endpoint with a port and the actual the definition of the task, which is the Docker image, environment variables, attached secrets, and so on. So in the Amazon world, that's called a service, and attached to a service is the service discovery piece. So I had to work out, how are we going to do the load balancing, and how are we going to define the endpoint? So a good AWS mapping for that was Route 53, and they have a relatively new service called the auto naming service, which you can hook into in the service definition. So we use that. And then the scaling pieces were managed by the OpenFaaS project. I didn't have to do anything there. I just had to define them as Fargate services and link them all together. And that was true for the asynchronous. To get asynchronous working, I just needed to deploy the NATS keyword, and there were no code changes required. So that was brilliant, really. That saved me a lot of time. The secrets were, that was a bit of a head scratcher, because a function expects a secret to be available as a text file under, run secrets. So if you have a secret called password, a function would expect that to be under /var/secrets, and then a file called password. And I think in Docker Swarm, that's handled by the infrastructure, the secrets manager in Docker Swarm. And I think the same thing for Kubernetes, but Fargate doesn't have sort of an integrated secrets manager like that. So I borrowed the technique that Andrew and Nick had used in the Nomad provider, and attached a sidecar container that pulled the secrets down from KMS, and then wrote them out as text files in the right place. And that seemed to work quite nicely. So this is the sort of deployment view of the Fargate solution. And you can see that we've got one service here at the top for the ingress, where the gateway and the provider are defined in the same service. And we've got this sidecar secrets attached, and that's used for the gateway to get the basic auth credentials, so the username and password. And then functions are at the moment proxied through the gateway to the Fargate provider, then off into a function which may or may not have a secret sidecar if it uses secrets defined in its YAML file. And then we've got the NATs over to the side here. And we've locked all the access down using Amazon security groups. So, you know, only the Fargate provider is allowed to call this function, as well as the key worker. And so we've used a lot of the sort of standard AWS elements to make it secure. Oh, sorry, I should have gone to that slide. And it's a bit blown up. We've also made heavy use of IAM roles, but this is something that you know, a user of OpenFaaS on Fargate they don't need to get concerned with this. This is all handled for you. But the secrets, the function's only given an IAM role that allows them to access the secret defined in their YAML file. So there's no way they could access secrets from another function if they happen to, you know, break out into this container and somehow get inside that process. So next on the roadmaps, we're looking to move our cloud functions over to this solution. I've got a couple of remaining tasks to do before we can deploy that into production. One of those is consuming events from CloudWatch. We rely quite heavily on scheduling, and the way that we're going to solve this scheduling solution is to basically use CloudWatch to pop a message on an SQS queue and then have that trigger a function on the solution. Would also it'd be good to get more people involved in this project and have some more users for sort of feedback. And yeah, I would like to present this solution to the AWS community and see if more people are interested in using this. And I'm preparing a blog article to put out on openfaas.com, which is sort of 90% done. So hopefully have that done in the next week.
That sounds really good, Ed. I like how you're solving that timers or cron issue by using CloudWatch. So there was something else that you had, I think people might be interested in. Do you think you built something with Terraform to support this?
Yes, we've got two Terraform projects. One Terraform project builds out this reference architecture. So if you just want to have OpenFaaS on Fargate, you know, out of the box, it's one script that you run and it builds all of this reference architecture, hopefully in, you know, in the best practice secure manner. And then the other Terraform piece that I did was to create a plugin to the main Terraform program itself, so that you can define your functions inside a Terraform script using the standard HCL. So if you're a Terraform user, that allows you to keep all your infrastructure as code in one place using your favorite tool.
Yeah, could you drop a couple of links for this into the Slack community after the talk?
Yes, yeah, I'll do that, yeah. That's the main repo, but there's two other repos for the Terraform stuff. Okay, yeah, that's everything.
Appreciate you preparing that for us. So we've got about 10 minutes left. What questions have we got for Ed about what he's built here?
I have a question around availability. What happens if, let's say, the zone where the gateway is running drops off?
Yeah, so at the moment, that service is scaled to 1, but it would be quite easy to scale it to 3 and have it run in all of the AZs. And then the ALB would just round robin requests. And then if one dropped out from an AZ, the ALB would notice that the health endpoint had disappeared.
Okay, so you've linked the health check in the ALB with /health in the gateway?
Yes, yeah. And that's proxied through to the provider. So that should work fine. So that was one thing that I'd missed in my initial provider implementation. I hadn't implemented the health Z. But then I noticed I needed that to do the ALB health monitoring.
Yeah, it's the same on Kubernetes, like the ingress controller will ping that helps the stuff. Yeah, so it's great if you can scale everything, right?
Yeah, because it's stateless. I think it's quite simple. I haven't actually tested it, but in theory, I think that would be quite straightforward.
Yeah, the only problem I'm seeing is with nuts. So with nuts, you cannot just scale to 3 because you'll have like 3 masters. What you need to do is make AWS spin a new NAT instance when the old one dies.
Yes,
that's
think
possible, but that's the only way right now we can work.
So I think
around the
some of the more detailed feedback, we can do this on Slack, raise an issue. Ed's definitely looking for participation or feedback. So Stefan, you know where to find him. I'm sure he'll appreciate a bit more of a detailed review. Do you have any other high-level questions about anything that we've looked at today? The FaaS providers, OpenFaaS Cloud on GitHub or GitLab, the community cluster with free access, or AWS Fargate?
I'm not on the community cluster. How do I get access to that?
Yeah, who's speaking?
Daniel.
With Daniel Grusso? Yeah, are
Daniel
you on OpenFaaS? Are you on OpenFaaS Slack?
I am.
Yeah, join the OpenFaaS Cloud channel.
Okay, will do. It's Daniel Payne too.
Oh, Daniel Payne, great.
Thank you.
I'll just have the quick comment that I'm definitely really interested in the Fargate work, and I'd like to get in touch with Ed later, just ask some questions. So it's great. I mean, it's really brilliant stuff.
Awesome.
Yeah, thanks. I'm more than happy to chat with people on Slack or do Zoom calls if people prefer to meet face to face.
Well, we've got a few more minutes, but what I wanted to say is we've got 3 really practical ways that you can get involved now. You can try the workshop. If you've not tried the workshop and you've not heard of it, and you kind of have a lot of questions or you're bumping into things, this is for you. And if you just want to get productive really fast, then this is the best way to do it. We've got about 8 to 12 self-paced labs. They all revolve around sample code, so you don't have to be a coder to even try them. And they'll teach everything that you need to know, from synchronous to scaling to even the Python bot that we saw. You can sign up and register for OpenFaaS Cloud using this gist on point number 2. It's a limited availability, so it's really first come, first served. And then you can join Slack if you didn't take the direct link. There's another way of getting in touch with us through that link there. Have you got anything else?
Sweet. This is up.
Say again?
I said, sweet. This is awesome. It's really cool to get to talk to all you guys and listen to what you're doing. I really like it.
It's great to have. It's great to have all of you here. This community is really, as I said, is built by everyone that's here, and this is just going to keep growing and growing. We need a bigger boat to fit everyone in. So great. I'm going to finish the recording now, and if everything goes well, I will upload this.